Welcome everyone to The Explainer. Today we are jumping straight into a botanical detective story to find out exactly what is making our garden sick. If you've ever walked into your backyard or maybe just checked on your indoor plants, only to find a withered leaf, a weird spot, or just a sudden collapse, you definitely know the panic that sets in. But today, we're going to learn how to read those clues together. So, who actually killed your favorite houseplant? Well, let's dive into this mystery by framing your garden as a literal crime scene. Here, fungi are our primary suspects, and you're the lead investigator. We're going to look right past that surface-level damage, skip all the guesswork, and use actual plant pathology to ID the real culprits. It's essentially a microscopic whodunit, and by the end of this explainer, we'll have all the tools we need to crack the case. All right, let's kick things off with Section 1, Investigating the Crime Scene. Before we whip out the magnifying glasses to hunt for pathogens, we first have to make absolutely sure a crime was actually committed. Because, let's face it, nature is incredibly weird and it plays tricks on us all the time. Take a look at the normal reproductive sori on the undersides of ferns, or that strange corky bark on sweet gum trees. What about those bizarre little cones on conifers? Those are literally just male pollen-bearing strobili. Now, all of these look incredibly alarming to the untrained eye, but they cause absolutely no harm to the plant whatsoever. They are perfectly normal anatomy. On the flip side, we have the true signs of distress: systemic wilting, aggressive spots, and structural collapse. So, step 1 is always separating the natural oddities from the true victims. And this brings up a great reminder not to jump to conclusions. Sometimes, like with secondary leaf spot on old evergreen foliage, you really don't need to panic simply because the leaf was going to fall off anyway. Broadleaf evergreens hold their leaves for about 14 to 18 months. As those leaves hit the end of their lifespan, it's actually incredibly common for them to get spotted by up to 50 different harmless fungi. The leaf has already done its job, it's retiring, and these fungi, they're just the cleanup crew. Secondary leaf spots will absolutely not attack your fresh new growth. Moving on to Section 2, Unlocking the Disease Triangle. Now, if an actual infectious crime is taking place, it relies on a highly specific set of circumstances. For a fungal disease to actually take hold and spread, 3 specific conditions have to exist at the exact same time to give our culprit both the motive and the opportunity. Plant pathologists call this the disease triangle. First, you need a susceptible host. That's a vulnerable plant, maybe due to genetics or some existing stress. Second, you need the pathogen itself, our fungal intruder. And third, you need a favorable environment. And for fungi, that usually means high humidity, soggy soil, or just really bad airflow. All 3 points of this triangle literally must connect for an infection to happen. So, what happens if you remove just one of those elements? Well, this is the crucial point. If any one side of this triangle is missing, or even just weak, the fungal disease simply cannot fully develop. Think about it. If you have a fungus and a super wet environment, but you planted a disease-resistant variety, boom, no crime occurs. Or if you have a vulnerable plant and a fungus, but you've spaced your plants out perfectly so the leaves stay nice and dry, again, the fungus is stopped right in its tracks. The power to stop the infection is entirely in your hands, as long as you know how to manipulate this triangle. That brings us to Section 3, Forensics, Signs versus Symptoms. To properly nail the culprit, our forensic investigation requires us to distinguish between the footprint left by the intruder and the bruise left on the victim. Notice the clear separation here between the signs, which are the actual fungal weapons, and the symptoms, which are just the plant crying out for help. A symptom is the wilting leaf, the yellowing tissue, or the dead spots. Symptoms definitely tell us the plant is sick, but they don't always tell us who made it sick, right? I mean, heat stress or overwatering can cause the exact same symptoms. So to solve the crime, we need the signs. Signs are the physical, tangible bodies of the fungus itself. The fuzzy mold, the spore clusters, the microscopic webs. Finding a sign is essentially like finding the murder weapon right at the scene. Let's get into Section 4, Profiling the Fungal Suspects. All right, let's bring our suspects in for police lineup and profile the most notorious fungal offenders you're going to face in the garden. Suspect number 1 is Alternaria, the absolute mastermind behind early blight. This one is highly methodical. It leaves these super defined concentric target rings as it tears through the tissue of plants like apples, tomatoes, and potatoes. It starts as this tiny water-soaked spot and quickly blows up into these large, dark brown, bullseye-like lesions which are often surrounded by a yellow halo. When you see a target, you are looking squarely at Alternaria. Next up in the lineup, we have the rusts. And let me tell you, these fungi are not subtle. They're easily identifiable by these striking, protruding orange pustules that literally erupt right on the surface of leaves. Inside these little blisters is a massive payload of spores, just waiting to catch a breeze and infect their next victim. They are what's known as obligate parasites, meaning they actually need a living host to survive, and they are incredibly efficient at hijacking your plant's nutrients.
Suspect number 3 is actually one of the oldest known plant diseases out there, powdery mildew. Now, while it just looks like someone lightly dusted your plant with flour, it's actually a pretty devious predator. Powdery mildew thrives in conditions with 97 to 99% relative humidity. It forms a thin layer on the leaf surface and then physically penetrates the epidermal tissue with microscopic root-like structures called haustoria. It literally acts like a vampire, using those haustoria to suck liquid food directly from your plant cells.
And rounding out our usual suspects is gray mold, scientifically known as Botrytis. This one is a master of survival. During dry, unfavorable conditions, it completely hides as these tiny, hard black specks called sclerotia. But the second the environment gets humid, it springs right into action, germinating into this gray, cobweb-like growth. It then disperses massive amounts of microscopic, grape-like spore clusters that can be carried away by the absolute slightest movement of air, infecting nearby plants with terrifying speed. Let's look closer in Section 5, Examining the Visual Evidence. Let's move over to the microscope and actually define the physical structures these fungi use to commit their crimes. To really understand fungi, you have to understand how they're built. The basic unit of a fungus is a branching, tubular filament. A single microscopic filament is called a hypha. But fungi rarely work alone. When millions of these hyphae gather together into a massive tangled web to attack plant roots or stems, we call that a mycelium. It's the mycelium that you're usually seeing when you spot fuzzy mold on your plants.
As the fungus matures and consumes your plant, it prepares for its next move. It generates fruiting bodies, which act as the launching pad for the very next generation of the pathogen. Whether it's a shelf fungus on a tree trunk, a tiny mushroom, or microscopic structures hiding in a leaf spot, the fruiting body's entire purpose is to manufacture and release spores to continue that cycle of infection.
And here we see the direct cause and effect of the fungal crime scene. On one side, we have the microscopic spores, essentially the tiny airborne seeds of the fungus. They hitch a ride on the wind, on splashing rain, or even on your pruning shears. When they land on a wet, susceptible leaf, they germinate. The result of that microscopic invasion is what you see right next to it. Devastating, necrotic leaf spots where the fungus has successfully killed the plant tissue and just set up camp. Finally, Section 6. Breaking the triangle. Okay, so now that we've profiled our culprits, examined the forensic evidence, and understand their methods, how do we actually stop the crime spree? Well, we defeat the fungi by breaking that disease triangle we talked about earlier. Step 1, choosing resistant plant varieties removes the susceptible host from the equation entirely. Step 2, spacing your plants out to improve air circulation eliminates the favorable environment, making it way too dry for fungi like powdery mildew or Botrytis to thrive. And Step 3, sanitizing your gardening tools and avoiding overhead watering directly attacks the pathogen side of the triangle, stopping you from accidentally spreading spores from one victim to the next. This brings us to a really empowering philosophy for plant care. Ultimately, gardening is a delicate balance. You don't always need to resort to heavy chemical sprays to fix a problem. Making even tiny, thoughtful adjustments to the environment, like watering the base of the plant instead of the leaves, or just thinning out dense branches, can entirely tip the scales back in favor of your plants. You take away the fungus's opportunity, and the disease pressure just collapses. Well, we have covered a ton of ground today. The next time a leaf drops or a stem wilts, resist the urge to panic. Instead, grab your magnifying glass and look for the signs. You are the lead investigator now. So what hidden fungal world are you going to discover right under your nose in your own backyard?